remember what it means to rationalize a denominator? Have you heard that term before? So it's basically just a way of rewriting your problem. So it's equivalent mathematically. If you plug them in the calculator, you get the same decimal back. But it's putting it in proper notation. And when we're dealing with radicals, it is poor notation to leave a radical in the denominator. So we always have to rationalize. That means get that radical out of the denominator. We need to move it up to the top. But when we do that, we have to make sure that our original problem is equivalent. So for instance, if I gave you 1 over the square root of 3. Okay, I always have somebody that just says, oh, yep, I can square, and that is 1 over 3. Is 1 divided by the square root of 3 going to give you the same decimal as 1 over 3? No. So this is not okay. We have to rewrite this problem so it's still mathematically equivalent. When we have fractions, we know it's legal if you multiply the top and the bottom of the fraction by the same thing, right? 1 over the square root of 3 is the same as 2 over 2 square root of 3, or 3 over 3 square root of 3. They reduce to the same number. So we know from yesterday, if I want to get rid of a square root of 3, I need a perfect square, right? What would I have to multiply by to make that a perfect square? Okay, I need basically a 3 under my radical. So I'm going to multiply by the square root of 3. Now if I do it on top and bottom, I haven't changed my problem because the square root of 3 over the square root of 3 is 1. All I've done is multiply by 1. When I multiply the top, 1 times the square root of 3 is just the square root of 3. When I multiply the bottom, I have the square root of 3 times 3, which is 9. But what is the square root of 9? Okay, check me. Grab a calculator. Type in 1 divided by the square root of 3. Then type in the square root of 3 over 3. Are they the same? Yes. I haven't changed my problem. I just rewrote it. So those are equivalent. And it is rationalized because the radical is no longer in the denominator. All right, let's try another one. If I said 5 over 4 square root of 2. Rationalize means we need that radical off the denominator. Is the 4 a problem? It's not under a square root, so it's not an issue. It's just the square root of 2. That's the problem.
So take both sides times the square root of 2.
Okay, so if I multiply by the square root of 2 on top and bottom. On the top, 5 times the square root of 2 is 5 square root of 2. On the bottom, 4 square root of 2 times the square root of 2 would be 4 square root of 4. But the square root of 4 is 2, so all that means on the bottom is 4 times 2, which is 8. So this one turned into 5 radical 2 over 8. Do you remember doing this before? Maybe a couple of you did. Okay, look at this one. The square root of 2 over square root of 3 minus square root of 2. All right. If I just multiply by a square root of 3, that would fix part of my problem. It would give me a square root of 9 minus the square root of 6, and I can do the square root of 9 But it didn't get rid of my other square root, did it? Okay, if I multiply by a square root of 2, would that fix it? No. It'll get rid of this one, but not that one. If I multiplied by square root of 3 minus square root of 2, what would we have to do on the bottom? We'd have to FOIL. So if I did that, square root of 3 times the square root of 3 is the square root of 9, minus square root of 6, minus square root of 6, minus the square root of 4. I got rid of some of them, but it didn't get rid of all my radicals. So how do I fix that? When we multiplied, it's these middle terms that didn't go away.
Yeah.
We need those to cancel, and that happens if you multiply by the conjugate. The conjugate is the same thing, but opposite signs. So instead of the square root of 3 minus the square root of 2, we do the square root of 3 plus the square root of 2. So we're doing the opposite sign. The reason we have to do that here is it's more than one term because of that subtraction. The previous problem, we had a 4, but there wasn't a minus or a plus in between there. It was a single term. Now we distribute. So we get square root of 6 plus the square root of 4. On the bottom, if we FOIL, we get the square root of 9 plus the square root of 6 minus the square root of 6 minus the square root of 4. On top, square root of 6 plus the square root of 4 is 2, and once you do the square root, the radical goes away. On the bottom, the square root of 9 is 3. Positive square root of 6 and negative square root of 6 cancel. Minus the square root of 4 is 2. 3 minus 2 is 1. Do I even need that over 1? It's turned into the square root of 6 plus 2. Alright. I want you guys to try it. Any questions on this problem? Here is yours. The question you have to ask yourself is, can I just multiply by the radical, like we did on our second problem, or do I have to do the whole conjugate, like I did on the last problem? If you just multiplied by the square root of 2 here, because of the subtraction, we have more than one term. You have to take each term times the square root of 2. And that would give you 5 square root of 2 minus the square root of 4. Does that get rid of the radical? No. So anytime you have more than one term on the denominator, so if you have an addition or a subtraction, you have to multiply by the conjugate. So the same thing, but change the sign in the middle. So now, if we multiply, we get 15 plus 3 radical 2. Denominator, we have to FOIL, so 5 times 5 is 25. Plus 5 radical 2 minus 5 radical 2 minus the square root of 4. On top, we can't do anything. On the bottom, we have 25. Positive 5 radical 2 and negative 5 radical 2 cancel. Minus the square root of 4 is 2. So I get 15 plus 3 radical 2 over 23. I'm going to put a couple more up here. We had trouble with that one.
If 23 was, I I did it accidentally wrong, I had 27 and then I simplified, you can do that.
Yes, but you would have to divide every
Yep.
single term. Let's do a couple more. What did you multiply by? Radical 5. How come you don't need the conjugate? Right, there's no plus or minus. This is a single term. So if I multiply by radical 5, I get 8 radical 5 times 3 radical 25. Square root of 25 is 5 times 3 gives me a 15. On C, what do we have to multiply by? Because I have an addition or subtraction, we have to do the conjugate, radical 3 minus radical 7. So we get 4 radical 3.
And isn't it with the conjugate, you can always just do the first one on both and the last one on both and skip the other ones because you know it's gonna be.
Yep, that's the whole point of the conjugate, those middle terms will always cancel. So we get the square root of 9. If you choose to show it minus radical 21 and plus radical 21, but like Selby said, those will cancel, so if you don't write it out, that's fine. So I get 4 radical 3 minus 4 radical 7. Square root of 9 is 3. These drop, minus 7. So I get a negative 4 on the bottom. Can I do anything else with that? I can simplify. I have 3 things. All of those can be divided by negative 4. So that would give me a negative radical 3 plus the square root of 7 in the end, if I go ahead and divide my negative 4. All right. Questions there? What if I gave you this one? 4 over the cube root of 3. Okay, if I just multiply by the cube root of 3 on top and bottom, is that going to help me? On the bottom I would end up with the cube root of 9. Can you do the cube root of 9? No. So a little more thought on these. We have to think, what can we multiply by so that I will have something I can do the cube root of? So I need to make this 3 into a perfect cube. What would I have to take it times? So like 2 to the 3rd power is 8. Can I take 3 times something and get 8? No, not unless you want to do fraction. 3 times 9. So on top I have 4 cube root of 9. On the bottom I get the cube root of 27. But what is the cube root of 27? I look at So this is the same thing as saying the 4th root of 3 over the 4th root of 5. I have to get the 4th root off the bottom. So what can I take 5 times so that it'll be something we can do the 4th root of? Everybody should be trying to figure it out. 125. On the top, I would get the 4 through of 375. On the bottom, I get the 4 through to 625. Okay, but what is the 4 through to 625? 5. Any questions on those two? So then another. So 2 over the square root of 12 minus 1 over the square root of 27. I have several issues here. I have radicals in the denominator, which we know we have to move. We also are trying to subtract, and if you want to add or subtract, what do we need? Common denominator. So we have to get the radicals off the bottom. We also then have to try to get a common denominator. It doesn't matter which one we do first. What do you guys? What are your thoughts? Give me a starting point. Probably 3 different options for where we could begin on this problem.
Couldn't you switch and do the reciprocal?
So multiply by like radical 12 on top and bottom. Is that what you mean? Or
Yeah, do, flip 1 to 27.
oh,
2 times.
that's if you're dividing, but we're subtracting. Okay, you want to start breaking down these radicals at least? Square root of 12. How would I break that down? Square root of 4 is 2. How do we break down 27? So that's 1 over 3 radical 3. Okay, give me a next step.
You can subtract now, right?
If the bottoms match, so they're close. We have a 3 radical 3 and a 2 radical 3. Can I reduce in this first fraction 2 over 2 square root of 3? Since it's one term, there's no addition or subtraction. You can cancel those 2's. So now if I'm going to make a common denominator, what do I need to do? They both have a radical 3. I have to take the first one times 3. So that's 3 over 3 radical 3 minus 1 over 3 radical 3. Now do the bottoms match? So now put them together. 3 minus 1 is 2 over 3 radical 3. Is that okay for my final answer?
No.
Get the radical off the bottom, so if we multiply by the square root of 3, we get 2 square root of 3 over 3 square root of 9, or 2 radical 3 over 9. Okay, definitely not the only way to do it, but at some point we had to break down those radicals, at some point we have to get the radical off the bottom, and at some point we have to get a common denominator. Although steps could have really been done in any order, but those were the 3 things we had to do. Let me give you guys a review problem to try. probably take a second and try this one. It's kind of a mix. 3 different places you could begin on this problem. I don't think anybody started just trying to get the radical off the denominator, but you could. Some people started breaking down the radicals first, and some people started with multiplying on the top. And both options will get you to the same point. I think I saw more people multiplying them together, so I'll start there. So this is what we were working on yesterday. If you multiply those radicals, you multiply underneath, so 8 times 2 is 16. M squared times m squared is m to the 4th, m to the 3rd. Okay, on the bottom, we have a 32 m to the 4th n cubed. Now, you have a couple options here. So some people started breaking down these radicals. Did anyone realize these are both under a cube root? Okay, when they're both under a cube root, you can multiply them. Can we go ahead and divide and reduce things? Yeah, we could. If we did that, 16 over 32, what would that turn into? 1 over 2. Okay, what happens to my m to the 4th? They cancel. What happens to my n to the 3rd? Cancels. That makes this problem really nice, saves me a lot of time. So I get 1 over the cube root of 2, so what do I have to multiply by to get that off the bottom?
Cube root of 4.
So that's the cube root of 4 over the cube root of 8, which is the cube root of 4 over 2. No matter which path you take, it would simplify there in the end. It was just definitely a lot faster to recognize that it was all one term, both under a radical, so we could divide. All right, questions there? I want, okay, I'm going to give you just a couple more review problems, and then we'll stop and work on homework, okay? What can you take out of the first one? What? A z to the negative 6. They both have z's. You take out the smaller exponent. So we have a 3. We took out all those z's, so it's gone. Plus 4. When you take out z to the negative 6, it's like subtracting. So negative 2 minus negative 6 is positive 4. Second one, what does the negative power do? Flips it. This would be 8 over 125. What does a 4/3 mean? With a radical. It's the cube root or 4th root? Cube root of this to the 4th. What's the cube root of 8? Cube root of 125. So 2 to the 4th, 16. 5 to the 4th, we get 16 over 625. Last one. A to the 3rd to the 0. Anything to the 0 power becomes 1, so that's gone. We have the -2, a to the -3rd, b to the 4th still. Okay, on the bottom, we do have the a's written twice, so what do you do with those exponents? Do we add or multiply? Add. 1/2 plus 3/2 is? Now we reduce. -2/4 would reduce to -1/2. Do we have more a's on top or bottom? Bottom. So if I bring this down, it's like minus -3. So that gives me an a to the 5th on the bottom. Do we have more b's on top or bottom? So minus -2 is b to the 6th. Or you could write it as just a negative b to the 6th over 2a to the 5th. All right. So you need to finish.
Any freshmen who have not taken pictures, please proceed to the library. Any freshmen who have not taken